Hello and welcome to Homework Walkthrough Video 8.03a, Independent Practice. Question 1. In the image, triangle ABC is similar to triangle DEF. DEF. What is the scale factor from DEF to ABC? What is the scale factor from DEF to ABC? So we're starting with the big triangle, and then we're going into the small triangle. Let's take a snip of this so we can draw. Scale factor is kind of like saying, what number do I multiply 21 by to get it to be 6? So 21 times what is 6? And 49 times what is 14? 49 times what is 14? And this question mark, that's our scale factor. So let's try and find what the missing number is for this first question. Start with 21, we end with the 6. What is that missing scale factor? 21 times something equals 6. Well, I can't think of it in my head, so let's try and use inverse operations. Inverse operation. Inverse operations to solve this one-step problem. We want this question mark all by itself, so let's move the 21 to the other side. We can move the 21, the times 21, to the other side by doing the opposite of what we see, the opposite operation. What is the opposite of 21 times? Yep, divide by 21. So our question mark will equal whatever 6 divided by 21 is. And looks like 6 divided by 21 is 0.285714, 285714, 285714, 285714, repeating forever and ever and ever and ever. And I think that's our scale factor, but let's see if we get the same number for this equation too. 49 times question mark equals 14. Let's use inverse operations and move times 49 to the other side using the opposite operation we see. Divide by 49. Question mark equals what's 14 divided by 49? Same thing. So you could just copy and paste this into your answer box like I did. Or you could type in 0.285714 with the repeating decimal bar. Or you could type it in fraction form, 2/7. Question 2, the image ABCD is similar to EFHJ. What is the scale factor from ABCD to EFHJ? Well, now we're going from small shape to big shape. Looks like that's 14. Okay, good. So scale factor is kind of like, what do I multiply the small rectangle by to get it to be the big rectangle? Or what do I multiply 4 by to get it to be 32? 4 times what is 32? And what do I multiply 14 by to get it to be 112? 14 times what? Oops. What is 112? We start with the ABCD, ABCD. Then we go to EFHG. So let's do these one problem at a time. 4 times what is 32? 4 times what is 32? I can't think that in my head. Shoot. But I can use inverse operations to solve this question. Inverse operations. Instead of timesing by 4 on the left side, I can move that times 4 over and do the opposite of timesing by 4, which is dividing by 4. Now I see my question mark. Question mark is whatever 32 divided by 4 is. 8. So I think my scale factor is 8. That's what I think. But let's test it out with my other math sentence and see if I get the same scale factor, because I should. So 14 times something is 112. Do the opposite math to the opposite side. So instead of timesing by 14, I will divide by 14. 112 divided by 14 should give me 8. Looks like 8 is my scale factor. I times this rectangle by 8, scale it up 8 times to get the purple rectangle. 8. In the image, ABCDE, ABCDE is similar to LMNOP, LMNOP. What is the scale factor from LMNOP to ABCDE? Okay. So we are going from LMNOP to ABCDE. So the big rectangle, or the big pentagon to the small pentagon. So we have to find, what do I multiply the big pentagon by? Times what equals the little pentagon? Or what do I times 84 by to get it to be 12? 84 times what equals 12? Or what do I times 105 by to get it to be 15? Notice I'm using similar sides right here. Both the bottom sides are in the same sentence, and both of these diagonal sides are in the same math sentence. Equals 15. Now, let's solve this scale factor, this question mark, one math sentence at a time. 84 times what is 12? Ooh, I'm having a rough time just thinking that. So let's use inverse operations to solve this math problem. So instead of timesing by 84 on the left side, let's move that times 84 over to the right side and do the opposite math. What is opposite of timesing 84? Yep, it's dividing by 84. So our scale factor should equal whatever 12 divided by 84 is. A repeating decimal. Let's see, where does it repeat? 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8. I think it repeats right there. 0 0.1, 4, 2, 8, 5, 7. Repeating. You can also write this in fraction form, probably by writing 12 over 84, or 6 over 42. I divide the top and bottom by 2, or 3 over 21, or 1/7. So any of these answers will work. Now let's try the 105 and 15 math sentence. 105 times what equals 15? I can't think that in my head, so let's use inverse operations to solve it. Instead of timesing by 105 on the right side, on the left side, let's do the opposite math to the left side. Divide by 105. So our question mark should equal whatever 15 divided by 105 is. Same thing. 0.14287, repeating, or you could also write it as a fraction as 15 over 105, or 3, divide that by 5 is 3, divide this by 5, I get 21, or 1/7. Looks like that's our scale factor. I'll type in the decimal. 0.142857. Get to my repeating decimal bar. 142857. Check. Or you could have also done 1/7 on a fraction. Question 4. A mural was painted in a building with dimensions of 42 inches by 84 inches. The mural was created to replicate a painting that was 6 inches by 12 inches. What is the scale factor from the original painting to the mural? What was the scale factor from the original to the mural? Original to the mural. So the mural was second, the original was first. Okay, so we're going from little rectangle, little painting, times what equals mural, big painting. Little painting times what is the big painting? Or 6 times what is 42? 6 times what is 42? And 12 times what is 84? 12 times what is 84? This question mark is our scale factor. How much are we scaling up this picture? What are we timesing each side length by? Let's find our scale factor one math sentence at a time. 6 times what is 42? I can't think that in my head. So let's try and use the inverse operation strategy. Inverse operations. Instead of timesing by 6 on the left side, let's move that over to the right side and do the opposite math. Divide by 6. 42 divided by 6 should give me my scale factor 7. Question mark is 7. Now, I think 7 is my answer, but just to be sure, let's find the scale factor for this second math sentence too. They should be the same thing, and if I did my work right, They will be. So 12 times what is 84? Let's use inverse operations and do the opposite math to the opposite side. Instead of timesing by 12, let's divide by 12. And 84 divided by 12 should give me the same scale factor. And it does. The scale factor is the number we times the side lengths by to make it bigger or smaller. Looks like our scale factor for this question is 7. We scaled up the original painting 7 times. A model that has a length of 12.5 inches is a replica of a real car that is 16.2 feet. What is the scale factor from real car to model car? Real car to model car. From real car to model car. So we're going from big car, the real car, times what? The scale factor equals the little car. Big car times what is the little car? So 16.2 feet times what is 12.15 inches? 16.2 feet times what equals 12.15 inches. Now, we can't do this problem yet because these numbers are in different units. They're apples and oranges. We can't do math with them. But if we turn these feet into inches, then I think we can. And we're back, and I fast forwarded ahead a little bit to check to make sure I was explaining it the right way. And turns out the units don't even matter for this question. So I'm just going to go ahead and erase them. The units don't matter. Doesn't matter if it's feet, doesn't matter if it's inches. It could be jumping jacks and push-ups. So what do I do to the big number to get it to be the small number? 16.2 times what is 12.15? Now I can't think that in my head. Right? That's a little hard to do in my head. I don't have my 16.2 times tables memorized. But I think we can use inverse operations to solve this problem. So instead of timesing by 16.2 on the left side, I can do the opposite math to the right side and divide by 16.2. And whatever 12.15 divided by 16.12 is, should give me my answer. 12.15 divided by 16.2, 0.75. Now, this question, maybe Mr. Bertram doesn't understand it as well as he thinks he does, but I think you should have had to turn 16.2 feet into inches and then found the scale factor. At least that's how you do it in real life. If the replica is 12.15 inches, I want to scale it up this much or scale it down this much. You have to keep it in the same units. But for this question only, the units don't matter. For this question only. And the answer is 0.75. All right, if you need more help with this question or with this homework, please let me know. I love to help. Good luck and goodbye.